So, hello student, I welcome you all in the unit 2 of lecture 6. So, lecture 6 is basically focused on the supervised learning and matrix for evaluating, right, which are the mathematical terms introduces in the supervised learning we will discuss here. So, how actual it is just calculated, right. Supervised, as the name suggests, supervised, that means supervisor will be there to calculating all that, training data set will be provided on the basis of the experience, on the basis of the observations, it is already there. But how you will feed the data, this will be basically focused on the calculation based. Na? So, how it is done? So, it will be discussed here later, it will be discussed in the next upcoming things. Now, basically what machine learning is, it's I will introduce here, and what are the types of machine learning? Types of machine learning means supervised, unsupervised and reinforcement. So, I will discuss here only the supervised learning of the things that is evaluated under this. So, matrix, in the matrix of the evaluating learning model will be discussed here. So, basically you have seen in the machine learning, that is obviously it is just a branch of the artificial intelligence, and this particular machine learning terms coined by American leader author Samuel. Okay. When it is comes under the picture, it comes into the picture into the 1959, okay, and basically it enables computers to self learn. But self learn means, yes, somebody is there for training the things to the machine, to train the things into the machine. So, the training data set is provided, the training data set will provided to feed the things in the machine. So, that is why it is said to be that enables computers to self learn, right. From where? From the training data set with the improvement of the time without being explicitly programmed. You have to add on time to time, right, because things are continuously changed. Na? So, there is a need to implement, there is a need to feed the things every time, right. That is why it is just a improvement of time, you have to feed your training data set into the machine, okay. And it allows, obviously you will prepare any kind of software for making all that, for doing all that. So, it allows software application with or without human intervention. After that, after implementing, after launching, there is no human intervention, but yes, once installed by the software will be installed with the person. Na? So, after this installing, the person is not responsible for doing all that, only the machine will responsible for doing the things and taking the decision, right. So, it allows software application with or without human intervention for more accurate prediction, isn't it? And obviously it will take the data, it will just take the data, it just provided the data whatever it is just happened in the previous year. So, it allows historical data as an input, it allows the historical data as an input for prediction and for taking the decision, okay. So, basically machine learning is categorized into the three parts: supervised, unsupervised and reinforcement learning. Supervisor, where supervisor is provided, where supervisor is there for guiding you the things. So many applications are there. I have told you about in the previous video what supervised learning is. Supervised learning is categorized into two parts: classification and regression. Classification technique is what? Classification, when you suppose any events has arises and you want to predict the things in which category it lies, right. How you will able to predict the things, and on the basis of something you have to take in the decision. Na? You will just predict the things. So, what was the condition, what was the thing? It will be basically categorized into classification and regression. Classification comes, so many applications comes under the classification: random forest, spam, email spam detector, diagnostic, decision tree, image classification, support vector machine. These are all the example of the classification techniques. Whereas, in regression means when the concept of dependent and independent variables comes. So, dependent and independent, on the basis of independent variable you will take the decision. Dependent variable is dependent upon the independent variable, right. So, independent variable is free, independent variable, according to the independent variable, dependent variable is try to take the prediction, try to take the decision, okay, and then after it will be able to predict the thing. So, regression, which kind of? Weather prediction, what would be the temperature for tomorrow, in the previous video you have seen. risk management, market trend, what is going on in the market, what is the happening after of this particular situation. Simple linear regression, multivariate regression, score prediction, it will be discussed one by one. So, in the upcoming video. So, regression and classification we will focus on this only, unsupervised learning will be focused in the upcoming unit. Okay. So, supervised basically classification and unclassification, and unsupervised learning is focuses in next video, where there is no any requirement of the supervisor, right. So, basically first you just understand how machine learning will work. Machine learning means, suppose since it is just a computer science terms now, so you will have so many example. You will have so many examples in the classification, right. So, basically what the machine learning, how you will feed the machine learning, how you will train the machine to learn the things. You will use any kind of programming language, right. So, if you have taken any traditional language, you have taken some, suppose you are taking in any language, C, C++, Java, you have taken this kind of language now for taking the output, and you want to train, and machine learning algorithm basically, how machine learning algorithm will works, it will obviously take input and it will also predict the things, right. So, if you are using the simple programming language, simple traditional language, obviously you have to feed the input and you will write the program, right. You will feed the input and you will write the program for that. If you are using the traditional programming language, any of the programming language, accordingly you will get the output, is not it. But if you are using the machine learning algorithm, what you will do? You will obviously give the input. You will obviously give the input training data set, and you will provide, here you will give the input and take the output, and here you will give the input and take the program and feed the output also, right. Suppose you are preparing for your exam, is not it. So, how you will do, what you will do, sorry, and how you will achieve the target? You will learn the so many problems along with the answer. In the examination, if this question will come, then I will write this answer. If in the exam, if they are asking this question, then I will write this kind of answer. That means along with the input, you are feeding the output also to, you will just train your mind for taking the desired output. Means you have to score the good marks, na? You have to score the good marks. So, what you will do for that? You will learn the things, you will give the input to your mind, and accordingly of particular input you will feed the output also. Means what would be the answer of the particular question you have just learned previously before facing the problem. So, you will implement this in the algorithm manner. So, machine, you have to train your machine like that. If the input is this, the output will be this. If the input is, if the situation is this, then output will be this. So, that is how the machine learning works, right. That means you have to feed input along with the output also, and your output may be in a programmed manner, right. And here if you are traditional, if you are feeding the traditional input, then what happened? You will just feed the input and you will just write the program for that, and after that, after calculating, after implementing this, then you are just able to find out the output, right. So, what metrics for evaluating linear model? Linear, I have told you na, linear regression and classification regression. So, linear regression is basically works on the dependent and independent variable, is not it? Dependent and independent variable. So, dependent variable is dependent upon the independent variable. You are just being as a student, you are independent, and whatever the output, whatever the result, of particular subjects, that is dependent upon your score point, right. If you are getting 50%, then you will comes under this category pass, and if you are getting just less than 50, you are just getting just comes under the category fail. That means dependent and independent, two things are there for knowing the for predicting the things, okay, for taking the decision. Obviously, it is all will be done for taking the decision. So, linear model or linear regression helps in finding the relationship between dependent and independent variable. So, why we require evaluation matrix? Basically, it requires for evaluating linear model, okay. It involves calculating an error score to summarize the predictive skill of model, okay. So, I have told you, I have taken the example in the previous video that your learning agent is try to cover, is try to take the, is try to give their output as it taken from the environment and is taken from the input from the supervisor, and it is very much close. Supervisor having a standard input, supervisor having the desired input, but actual input or output is supervisor has a desired output, but learning agent will perform all the tasks, and after that it will very much close to the desired output, that will be whatever it is, that will be the actual output. These are the two things, right. So, how many obviously your actual output will not as the standard output, you are just very much close to that actual output. So, this is how, this is basically you will just calculate the things how much you are closer to the accurate actual output. So, matrix is used for evaluating just a linear model or involving calculating an error score to summarize the predictive skill of a model. So, regression model basically predicted the modeling is the task basically to approximating a mapping function f from input variable x to a continuous output variable y, okay. Input variable x to a continuous output variable y, that means you can write like this, right. So, regression predictive model is the task of approximating mapping between function f from input x to a continuous output variable y. So, y is the function of the x is free from here, x is the independent variable and y is the dependent variable, okay. So, matrix basically, what matrix you will use for this? Basically you will use these three matrix. First basically regression analysis, what it is? Basically it is a way of mathematically differentiating variable that have an impact in giving the answers of important variable. But for evaluating these reporting of performance of regression model, we have basically three error matrix. Some other matrices are also involved, but we are focusing more on this: mean square error, root mean square error and mean absolute error, okay. So, mean square error and root mean square error, how it is calculated? These are also having the same some formula for calculating the thing. You are first you just know the what is the actual output and what is the desired output. Desired output will be given from the supervisor and actual output the learning agent. Learning agent may be anybody, you and somebody else, learning agent who will learn from the surrounding, who will learn from the environment, and supervisor will guide you. Supervisor may be your teacher, may be your parents. So, supervisor may be anybody, but under that supervision you will just act accordingly, you will just do this and you will just find out the answer, okay. So, in here mean square error is basically how it is calculated. Mean square error states to finding the squared difference between the actual and predicted value, isn't it? Actual here y is the actual output. I have written na y equal to what? F of x. So, y is the actual output and y that is predicted output. Actual output and predicted output. When you will get the differences between these actual output and this is predicted output, So, then you will just make it a square and it is just divided by the total number of samples, then you are just able to find out the mean square error, right. And in the computer terminology, basically how it is calculated, suppose you are using Python, you are using MATLAB, how you will feed the data, how you will able to find the mean square error, you will write the program for that, right. So, mean square error, you will write nothing, you have to import some already given file and accordingly you just expected the things, the desired, the expected value that is provided by the supervisor and predicted, that means you just find out the actual output, what would be, maybe some deviations in each points, is not it. This is expected, this is the standard and this is predicted output. That means ki some variations, obviously you will not very much sure that output is fixed, right. So, you have calculate the things and you will just find out what are the basic differences, how you will calculate that, you will just take the differences between these two and you will find out, take the square and divide the total number of sample, here the total number of sample is 11. So, total number of sample, then you will just find out the actual output, then you will just find out the output, that means mean square error is this, right. So, mean square error basically you in the computer manners in this, right, means some calculations are there, you have to reach the near the destination, right. So, you have to very much close to the destination with the help of these mathematical functions, with the help of the mathematical evaluation. So, after running the example, first report the expected value and predicted value, this is the expected value, right, and here it is already feeded on the basis of your observation, on the basis of the training data set is provided, it is already feeded and this is just a way of writing, right, do not be bothered about that how it is done now. So, if you will just know about the Python, if you will just know the machine, any of the language of machine learning, it is already discussed how, what are the platform, what are the framework required for the machine learning programming in the unit 1, right. TensorFlow, PyTorch, so many examples I have taken in the previous video. So, these are the fix. This is just a fixed format, you have to feed only the training data set and you have to feed the predicted data set and after that you will just find out the calculation, you will take the calculation and after that you will just print it out and finally your result will be in that manner, will be result will be appeared here. So, value and squared error for each case, every case, for every case your result is like in this manner, right. So, mean square error and you can take root mean square error, obviously when you will find the mean square you can take the root mean of square, then this comes under this category root mean square, right. It is simple square root of mean square error, okay. And the next method is the mean absolute error. Basically absolute error, obviously as the name absolute will be, because you are very much closer to the actual argument, to the desired output. So, the things you will just helpful to achieve the desired output is this. These are the metrics, these are the terms, these are the terminology that you will find to achieve the metrics, right. So, it calculates the absolute differences between the actual argument and predicted value. So, do not be confused, do not be bothered of the actual output means whatever learning agent will find out, predicted value whatever just supervisor will told you about that ki yes this will be happen in the future. On the basis of what? On the basis of their observation, on the basis of their predictions, on the basis of their experiences, right. So, these two value exist now. So, how, which one is very much impactful, which one is very much easy to told you about the result. So, these are the way by which you can predict the thing, by which your machine will able to do the thing. You have to, you know the problems and how it is feeded. I have told, I have shown you here. This is the way in the machine learning, I am talking the machine learning, that is why you have to write these things into this manner, right. So, after that you will be able to predict the situation, right. So, mean absolute error is basically you will just take in the base value, that is actual output, that is the predicted output, and take the mod of that. Mod means just a actual, though no minus no plus, you will just take out the final result, and finally you will just divide by the total number of data points, total number of data samples, then you are just able to find out the mean absolute error. Okay. So, which one is very much right? You can see with this diagram. Mean absolute error will predict you the things very smoothly, right, and mean square error is, result will be some fluctuated, some slanted way, some variated way, right. So, line plot with this you will take your prediction, here it is predicted value, here it is the mean square error, and what it is and where you will lie, these 2 points will helpful you. Okay. So, machine learning is actually works on the things, what the input will be and what would be the output if the input value is this, it is already feeded in the machine learning algorithm, and then after you will just able to make the output. So, the things, how the things are calculated, so these are the way by which you can calculate the things, and finally you just able to take the decision, you will just able to take the decision, isn't it. So, here in the classification technique and the regression techniques, these were the techniques that are categorization of the supervised learning. First you decide in which category it will lie, and then after you will just calculate the things for getting the accurate result, and after this accuracy then you will just your model is just behaving as a in an accurate manner, right. So, classification and regression. Classification means the data will comes under which class, under which category, and the regression means dependency and independency. The two terms has coined here, dependent and independent. Which one is independent variable? On the basis of that independent variable, you will just take out the prediction. Dependent variable will tell you about the dependency. So, here this is the independent variable, and this is just a dependent, it is dependent upon which value, on this value. So, dependency and independency, these are the two terms that comes under the regression, and that is why it is categorized into the linear and non-linear part. It will be discussed later, linear and non-linear. Linear means when the independent variable are only one independent variable are moving around here and there, and you are taking the decision. Dependency is depend upon the only single factor, and in non-linear is dependency is depend upon the more than one input variables. So, that there non-linear regression comes into the picture, and how it is all calculated. So, these are the metric, these are the way like mean square, root mean square, error. So, any of the method you can take for taking the decision, right. So, I hope this video will helpful to understand the supervised learning and its matrix and how it is done, it will be helpful. So, thank you so much for watching this.